Before going to more details, let's see what is ECU. An engine control unit called ECU, also known as Engine Management System or EMS, is an electronic device, fundamentally a computer that is part of an internal combustion engine, which reads several sensors in the engine and uses the information to control the ignition systems of the engine. This approach allows an engine's operation to be controlled in great detail, allowing greater fuel efficiency, better power and responsiveness, and much lower position level than earlier generations of engines. Because the ECU is dealing with actual measured engine performance from milliseconds to milliseconds, it can compensate for many variables that traditional system cannot, such as ambient temperature, humidity, altitude or air density, fuel octane rating, as well as the demand made on it by the river. In addition, to a large degree, it is able to compensate for the gradual wearing of the engine as it ages, which is practice allow it to be extended engine life to 2 or 3 times that of engine or 20 years ago. Let's move to the second topic, modern ECUs. Modern ECUs use a microprocessor which can process the input from the engine sensors in real time. An electronic control unit or ECU contains the hardware and software or firmware. The hardware consists of electronic components on a printed circuit board called PCB. The main component on the circuit board is a microcontroller chip called CPU. The software is stored in the microcontroller or other chips on the PCB, typically in EPROM or flash memory, so the CPU can be reprogrammed by uploading updated code. This is also referred to as an electronic engine management system called EMS. Earlier ECU designs. Earlier ECU designs were based more on analog computer circuitry, because analog circuits are not limited by clock speed. It was not until around 1987 that digital electronics and embedded microprocessor systems became fast enough to process engine parameters in real time. The first such systems were introduced into racing engines, such as those used for Formula 1, but it was not long before these found their way into every cars. A hybrid digital design was popular in mid-80s. This used analog techniques to measure and process input parameters from the engine, then used a lookup table stored in a digital ROM or DROM chip to yield precompiled output values. Later systems compute these output dynamically. The ROM type of system is amenable to tuning if one knows the system well. The disadvantage of such system is that the precompiled values are only optimal for an idealized new engine, as the engine wears the system is less able to compensate than a CPU based systems. Let's move to the next topic called sophisticated engine management systems. Sophisticated engine management system receive inputs from other sources and control other parts of the engine. For instance, some variable value timing systems are electronically controlled, and turbochargers, waste wires can also be managed. They also may communicate with transmission control units (TCU) or directly interface electronically controlled automatic transmissions, traction control systems, and the like. The Control Area Network or CAN bus automotive network is often used to achieve communication between these devices. Such systems are used for many internal combustion engines in other applications. In applications, the systems are known as FADECs or Full Authority Digital Engine Controls. This kind of electronic control is less common in piston engine airplanes than in automobiles because of the large cost of certifying parts for aviation use, relatively small demand, and the consequent segment of technological innovation in this market. Also, a combusted engine with Montego ignition and a gravity feed fuel system does not require any electrical power to run, which is safety bonus. Race ECUs. Modern ECU-based ECUs have on-board diagnostics with which they can diagnose engine faults stored as fault codes in their internal memory. When the vehicle is serviced, an engineer connects a fault code reader or scanner to the engine and inspects the stored fault codes. These codes fall into two categories called industry standard codes. Those are common to all vehicles in the class, and manufacturer specific codes. A special category of ECUs are those used by the automotive racers. These units do not have a predefined fixed behavior but are programmable or mappable. Since a race car often has a modified engine, the behavior of ECU must be modern as well to adapt it to new working environment. The ECU can often be programmed or mapped while the engine is running. By connecting a laptop to it uses a serial or USB cable. A map consisting a large number of configuration parameters tells the ECU how it should control the engine given a number of scientific sensor inputs. An example of this is the amount of fuel to be injected into each cylinder, which varies depending on